Okay, let's do this. Hi everyone, Jeremy here, and today I need to explain a little bit what's going to happen in the coming days. I started this series about rewriting functions in Rust, and it turns out I'll be on vacation soon, so I won't have too much time to upload and stream videos. What I'm going to do instead of going on in this series right now is show you a little bit of functional programming in JavaScript and in Rust. In order to do that, we are going to need a topic or a problem that we want to solve. And what we are going to pick is a Scrabble solver. A Scrabble solver is you have probably already played this game. Scrabble is a game where you put letters together, forming words, and each letter has a total score, and the goal is to actually build the longest or the most point generating words that you can. So we're not gonna build a full Scrabble game, but we're gonna try to build a solver. What I mean by a solver is a program that is gonna take an input. The input is gonna be words. Words that will be a list of all the words that have been written by someone. It's gonna be like hello world, etc. And those words are going to be comma separated. And what we are going to do with these words is we are going to iterate through each letter. And given this scheme here, these letter values, we're going to try to sum it up and figure out how many points a certain player has in total. And in order to do that, since we need to actually iterate over each value, each letter here, like H will be worth, I don't know, 3 points, E will be worth 1 point, L will be worth 2 points, etc. And we want to sum up each of the letters' values. So in order to do that, we are gonna use a couple of functions that are known to be like the building blocks of functional programming. The functions we are going to have a look at today are map, filter, and reduce. Those are very interesting building blocks in JavaScript, and we are going to have a look at their equivalent in Rustlang then. So let's start with map. As you can see here in the MDN web docs, a map method creates a new array with the results of calling a provided function on every element in the calling array. What does it mean? It means that here, in this example, which we are going to run right now, in this example, I'm going to iterate through each of the values and apply a function to it. And it's going to return me a second array, which has the same length. If I have, for example, an array with 10 values, I'm going to end up with another array of 10 values. And it's going to just apply the function. Here the function is x times 2, which means I'm going to iterate through each of the function of the values, and I'm going to apply it. That means I'm going to first reach 1, and I'm going to double it, and then I'm going to reach 4 and double it, and 9 and double it, etc. Which is why the answer here, by mapping this function to this array, would be double the values for the second array. So 1 is 2, 1 times 2 is 2, 4 times 2 is 8, etc., etc. That would be a map. A map is going to be useful to us because the letter values that we have here are all capital letters, and we are going to need to maybe transform them or use a function that will give us the score of the number of points that a letter is worth. We're going to see that soon. The second function that we are going to use will be filter. Now a filter is a method that creates a new array with elements that actually pass the test implemented. For example, if I have an array of words and I want to use a filter function that just takes words that have vowels, I'm going to write a small function that returns true if it has a vowel, or return false. And through this filter, I'm going to apply it to an array, and I will only get I will get another array, and in this array, I will only have the words that have vowels. So here, this is not exactly the example that you can see. Here, we are filtering over all the words that have more than 6 letters. As you can see, when I run it, spray has less, limit has less, elite has less, exuberant, destruction, and present have more. So those are the remaining words, okay? This is going to be useful because I said that the words that are given that would allow us to compute the score are comma separated, and comma does not have any value in our Scrabble game. There is actually no comma in the game. So we are going to filter out the commas, and then we are going to iterate through each letter to get its value. And in order to compute the sum of these letters to see what the score is actually is, we are going to use a third function, which is a reduce. Now, reduce is a function that takes an accumulator and a value, and it applies a function. It applies a function to the current value and maps it to the accumulator. Now, it's kind of hard to grasp, but I'm going to show you an example later. Basically, we start with a value, and we will iterate through each of the members of the array by applying a function to the accumulated value. Let's, for example, try to sum something. Let's say I have a sum, 1, 2, 3, 4. I'm going to start with 0, and I'm going to iterate through each of the values in the array, and I'm going to add them. That's going to be 0, plus 1, that's going to be 1, then plus 2, that's going to be 3, then plus 3, that's going to be 6, then plus 4, that's going to be 10. Okay, so this is exactly what is being shown here. That's the reducer. The reducer here is just applying, is just summing the current value to the accumulator. Here, the accumulator would be 0, as you cannot see actually. Here it is. It's actually accumulating from 0 to the values, and here we can start with another value. For example, I don't want to start with 0, I want to start with 5. Okay, let's reduce it, and we start with 5, add 1, that would be 6, add 2, that would be 8, add 3, that would be 11, add 4, that would be 15, which is the exact result we are getting. Now, I know these three functions are pretty hard to grasp, so we are going to go ahead and write a couple of examples in JavaScript, and then we are going to see the equivalent in Rustlang. Okay, so let's go ahead and write it in JavaScript. Now, I have an index.js file, which you can see here. And the first thing I'm going to do is try to write something that can map into something else, okay? We are going to start with something very easy. We need maybe a list of words. This list of words is supposed to be comma separated, as I said. I'm going to copy paste it. We are going to write something like this. Hello world, this is a functional programming tutorial in JavaScript and Rust, okay? And we are going to try to apply something. Let const even mapped values equals words dot map, and here something is supposed to occur, okay? And we are going to console.log the mapped values. There you go. So in order to map, to do an array map, we actually need a function that will do the transformation. So let's try to create it. Const, let's say that we want to make it all to uppercase, for example. Letter to uppercase. It's a function which takes a letter, which we are going to call L here. No, which we are going to call letter. We don't need to make it harder than it is. And we are going to call letter. And the function in JavaScript to make a letter to uppercase would be this one, okay? So right here, I have a function that takes a letter and returns the uppercase one, okay? So words.map with this function would get me the map values. Let's try that. Node src. It's not working. It's not working. Why is it not working? Because I have words, and words is a sequence. It's a string. It's not an array. What I want to do is actually split the words with an empty pattern. So I will get all the letters, and I will then have an array to iterate over. There you go. Now I'm having a nice array, as you can see, with the capital versions of the letters, okay? So that means I've been able to map this with this function, all right? So it's pretty interesting to see that I can actually use this and put it here instead. Let's see how it goes. I get the exact same result because I actually just did the same, okay? So this would be a very simple map function that takes a letter and that makes it uppercase. If you want to learn more about it, you want to play a bit more and figure out on your own, try to fiddle with the game a little bit and see how it works, how it behaves. There are two things that you need to make sure. You need to make sure that the function you are applying returns something, or you will end up with an array of empty values, like an array of nothings. Oh, and you want to make sure that you can test this. It's actually not too hard to write as a for loop, for example. For, you could actually write it with a very simple for loop, which I'm not going to do here, but for each character, then return the uppercase one, okay? The second function we talked about was the filter function. So the filter for me, my goal in the Scrabble game is to actually return all the letters and no commas, okay? Const filtered characters is a function that takes a letter. I'm gonna just for okay, filter letters is a function that takes a letter and that returns true if I want to pass the filter or false if I don't want it to pass the filter. I do not want the letter to go through if it's a comma. So let's write this. Letter isn't, if the letter is not a comma, I want it to return true. If it is a comma, I want it to return false, okay? So I have my mapped values here. Let's try to filter values. And we are going to start with words that split, the same way we just did. And then we are going to apply a filter. And the filter is what we have just written above, okay? And we want to log it, of course. There you go. I'm running it. Now I just have lowercase letters, of course. And as you can see, there is no more comma. There is no more separator, okay? So this is good. A last thing I wanted to show you first is that we can actually chain the functions, which make it actually more convenient to read, and it's pretty interesting. So I'm going to do two things. The first thing I'm going to do is I'm just going to put that here. All right. And the second thing I'm going to do is uppercase no comma letters equals word.split to make sure that I get an array of letters instead of a string. Then I want to make it all uppercase, and then I want to filter out the commas, okay? I could have actually done this the other way around, first filter, then map. That would have maybe been a bit better. But since the title of this episode is map, filter, reduce, I'm gonna keep it that way, okay? So uppercase no comma letters would be the uppercase version without the commas. And we have the uppercase version without the commas, okay? This is great. The last thing we actually want to do is to not have the letters, but the total score, okay? So what I'm gonna do here is I have prepared the letter and values, which are here, as you can see. These ones, I have already put them in a set, which I'm gonna just copy paste it. We're gonna go through it together to make sure that everyone understands. So I've created a map, which I call the Scrabble Values, which is here. That is a set with all the letters and the corresponding values, okay? So now that I have this, I can actually create another function, which I'm gonna call const to Scrabble Score, that is going to take an uppercase letter. Now you understand why I first wanted to make everything uppercase. I could have just built my set with lowercase values, but that's not how it was written. That's not how it was displayed on the web page. So to Scrabble Score is a function that takes a letter, an uppercase letter, and that actually gets the corresponding score from the Scrabble values. So I'm gonna go Scrabble values.get letter. All right. So now I have a function that is named toScrabbleScore that gets the actual value that corresponds to the letter, and that returns it. Okay. So what I'm gonna do here, now that I've filtered out the commas, I'm gonna map again, because why not? I'm gonna map again and map it with the toScrabbleScore function. Let's see what happens. Oh, that's interesting. Now what we have is all the scores in order for us to actually get the total value, okay? So now what we can do is for, I haven't written, let's I equal 0. I haven't written any JavaScript for ages, so I'm sorry if I make any silly mistakes. We are going from I to the length. I think it's supposed to be a function, I don't remember. And we are going to increment I until we get to the length -1. So we are going through all the values in the array. And once we have done that, what we want to do is actually sum it. So let total score equals 0. We're getting there, total score plus equal uppercase no comma letters of I. And let's try to print total score. I'm going to comment that out because I don't really need it. Oh, I'm doing something silly here. Length is not a function. Okay, that was the other way around. Yay, that's good. Okay, now I have 102 points. I have maybe made a mistake. I don't know. Anyways, now I have... Oh yeah, I have made enough by 1 error, I think. Let's have a look at that. Yeah, I've made enough by 1 error, which I've been able to figure out. The thing is, I'm starting with 0 and I'm ending at the length. So I am not gonna go behind. I mean, I'm not gonna go beyond the array. So this is better. So basically, I'm just iterating through it and incrementing the score. This is exactly what a reduce does. This is what a reduce can do. It starts with an accumulator. That would be our accumulator. and it computes something that is going to be the accumulator of the next iteration of the loop, okay? I am starting with an accumulator, and I'm going to make a computation that is going to end up being the accumulator of the next iteration of the loop, okay? Let's try to do that together. Const to compute tool, it's gonna be a function that takes an accumulator and a current value, and that actually returns the accumulator plus the current value, okay? What does it mean? It means that now that I have the Scrabble score, I can reduce over it with a callback function that is the compute total that we have just defined, and an initial value. The initial value is 0. So this here is the same as this here, okay? Let's try that and see how it goes. I'm gonna remove that. I'm gonna... Okay, total score is not defined. This is true. 103. You see, it just behaved the same way. Now we are gonna make things a little nicer, let's say that. The first thing is I want to map the letter. Okay, I want to filter the letter to remove the commas, then I want to make them uppercase, and then I want to get the score actually. There you go. And then I want to use the reducer that I've just defined here. And log it. I'm going to run it again. Okay, so this here would actually be a function that is called const get total Scrabble score. And this function actually takes words, which we have defined above, and it returns exactly this. All right, let's see how it goes. Get total Scrabble score of words. Still 103, that's good. So this here is something that can actually be pretty well read. I mean, in order to get the total Scrabble score, we start with words, we split them into letters, we filter the commas out, we make them to uppercase, and then we map the letters to get the Scrabble values, and we reduce the values starting from 0 by summing them. Okay, so that's how one would get the total Scrabble score in JavaScript using functional programming. There are other ways to do that, but we don't want to look at it too much, but that's basically what we can do. Okay, let's try to reason about that in Rustlang for now. So in order to do that in Rustlang, what we are going to need is a set of really closely related functions, which are iterator functions. Iterator functions are all the functions that can be used on an iterator. It's like one of the most important documentation pages you can find in Rustlang. I would say the result and option APIs are also very interesting. The HashMap API is also very good, but this is one of the most important ones. You want to have a look at all the functions that are implemented here. I'm just going to pick the 3 that we are going to use that are relatively the same as the one that we have just used. Okay, so the first one would be map. We're not going to have a look at the definition because it might be a bit confusing if you are not too used to Rust. What we're going to have a look at is the basic usage of the function. So basically what is going on here, we are still having an array. We are having a closure, which is the function that we are gonna use to iterate through the array, which is double. So that's the exact same as the JavaScript version. We are going to double each of the values. And as you can see in the assertions here, we are doubling 1, it's going to be 2. We are doubling 2, it's going to be 4. We're doubling 3, it's going to be 6. Okay? And as you can see, so the iterator next function returns an option. An option can be sum with a value or none. So here, that's why you get the sum and none everywhere. Okay? The second function that we're going to have a look at is filter. So filter, I could have actually just scrolled. I think it's like the third function. Yeah, anyways. So the filter is the exact same as the filter in JavaScript. It takes a value and it must either return true if you want the value to just keep on going through the data flow, or if it returns false, it's just going to be filtered out. Okay, so we will get another array which has as many elements as the array before, or maybe less if some values get filtered out, and it's going to apply a function, see if the result is true. If it is true, it's going to keep the value in the array. If not, it's going to just take it out. Okay, and the third. Here is the moment where we are actually expecting to find a reduce, but as you can see here in the documentation, it's pretty well explained. The equivalent to reduce is actually fold. It's actually fold, and it behaves almost the same as in JavaScript. The only difference here is that the closure you have that takes an accumulator and a current value is actually the second parameter. I'm going to show you that again. Here you have a fold function that takes the initial value first, and then the closure that has an accumulator and a current value. Whereas if we have a look again at the reduced documentation, it behaves the other way around. You get the function first, the closure, and then the initial value. That's the main difference we want to keep in mind while we are writing our solver. Okay, there are two things I wouldn't want to talk about too much, but I'm just going to go ahead and tell you a little bit about, which are hash maps in Rustlang. A hash map in Rustlang behaves a bit like the map in JavaScript, but there's a couple of things to consider when we are using it. It has two different APIs. Those are all the methods that we're going to need. We want to insert values into it. We want to get value into it. And sometimes we want to remove and this kind of stuff. This is not something that we are going to cover here, but I strongly advise having a look at the API because it's pretty well thought. And the entry API is something that's very interesting too. Okay, and the last thing I wanted to tell you about is the lazy static crate. Now the lazy static allows you to compute something only once and reuse it. It's not really a singleton, but it's something like that's the thing that is gonna allow me to create the Scrabble values, which I have just done in JavaScript. I'm going to put them here as a static, and I'm going to use it in the main function. So we've been talking quite a lot. It's been quite a bit of information here. So why not go back to the code and see how it goes? I've just told you about the hash map and this kind of things. I'm going to copy paste the Scrabble value initialization here, and we are going to have a look at it. Okay, so the Scrabble values here is a hash map of a character, which is on the left. Oops, sorry. And a value, which is on the right. The left-hand side is the character I'll be searching for, and the right-hand side is the value, so the score of each of the letters. Okay. Once we have this, there's another thing that we can do, which we have done on the JavaScript side. So I'm going to do that here, is to provide a function that allows, given a character, to give us the actual value. Okay, so I'm going to create a function which is called get Scrabble value, which takes a character. Let's say it's a letter because I said it was a letter before. and it returns a value. We know the values are always positive. The maximum value here is 10, so it fits in a U8 in an unsigned integer, in a small unsigned integer, okay? And what we're going to do here is return the Scrabble values. So that's almost what we would get in JavaScript. There's a couple of things to consider, though. As you can see, it's complaining. It's complaining for two reasons. Three, actually. The first reason is that the get function of a hash map returns a reference. It takes a reference and it returns a reference. So what I'm going to do here is ask for a reference. And it's still going to complain because it returns a reference. And it's even more. It does not only return a reference, it returns an option of a reference. Because if you are looking for something that is not in the hash map, you will get none. If you are looking for something that is in the hash map, you will get some and the corresponding value. Okay, so since we are having an option, I am gonna use it. There are several ways to handle options. I am probably gonna make it a subsequent video someday about how to use option correctly and what to do. Since the Scrabble value is gonna be used to compute the sum, to compute the score, what I'm gonna do is I'm gonna open the package. Basically, I'm gonna open the option, and if I don't have any corresponding value, I'm just gonna return 0, so it won't have any impact on me computing the total score. Okay, and oh, I was a bit too fast. I'm gonna do that again. And the second thing I just did was having a look at the compiler complaining that I actually. So yeah, this is a weird sentence. We had a talk about it on Twitter lately. I was actually supposed to return a U8, and I got a reference to a U8. As you can see here, I'm supposed to return a U8, and the get here function returns an option of a reference. So I'm going to dereference it. Okay? So either there is something, so I can get the value out, or there is nothing, so I'm getting a reference to 0, which I get out, and it just gives me a U8. Okay, so now let's write a main function, which is gonna start with the words. So I'm gonna get my my sentence again. That was "Hello world. This is a functional programming tutorial." If I recall correctly. There you go. I'm gonna copy paste it. It's easier, and I'm gonna need to write a function that is named getTotalPoints, and that does the job, okay? But in order to do that, I'm gonna do it the same way I just did in JavaScript. So the first thing I wanna do is start printing stuff to see how it happens. And let's call that result. And now we are gonna try to write functions. So let results equals, so the first thing we did was, I'm gonna put it on the side just to have a look at it. So the first thing we did was split things, split the sequence of characters, split the string into a sequence of characters. So what we actually have in Rust is chars here. So it's actually just getting the chars. I'm not really sure I can run this. Yeah, there you go. Oh, I don't need that, sorry. And now it's complaining because I am not supposed to just display a character like this. There's something I can do is actually debug it as it's written here. That's very nice of you. Thank you, compiler. It's telling me that I might want to use this instead. Okay, so now I have an iterator with all the funny values here so those values are the ASCII characters. We cannot see them as well as we used to in the JavaScript version. But let's just go ahead with that, okay? So this is the chars. That would be the first part of what we wanted to do. And then we are gonna filter out the commas. So let's try to filter it out. Filter. So as you remember, the filter takes a closure. The closure is a function that takes a letter and tells us if the letter is a comma. If the letter is not a comma, it's okay. Now it's complaining. It's complaining for something that is a little bit like what happened with our hash map. It's that we are comparing a reference to a char against a char. This here is a reference to a chart, as you can see. So what we're going to do is we are going to dereference it. There you go. There's a couple of magic tricks involved here. Can I do that? No, that's not what I want to do. I want it to dereference it. I want to get the value in it and compare it against a comma. Okay, so I don't really know which character a comma is. Let's try to figure it out. H-E-L-L-O, that's 5 characters. The sixth one, 1, 2, 3, 4, 5, 6 should be 44. Oh, there's still 44. I'm doing off by 1 errors live. That's pretty interesting. Let's make it a bit bigger so I can have a look at it. 104, 101, 108, 108, 11. Okay, it turns out it did not work out as I planned, I suppose. Let's see what happens. 104, 101, 108, 108. Okay, so that's not what I wanted to do. So the filter is keeping all the letters that are not a comma. That's very interesting. What am I going to do? I'm going to collect it. And I probably am going to collect it into a string. So I can maybe have a look at it. Can I do that? Yes, let's have a look at it. Hello world, this is a functional programming tutorial in JavaScript and Rust. Wow. So it seems like it worked, but somehow that's not what I got here. Let's remove this filter and see how it behaves. Hello world, this is a functional programming tutorial in JavaScript and Rust. Well, that's a weird experience. I don't know what's going on. I'll have a look at it later. If you found out what's going on, please let me know in the comments. I'm pretty sure you have seen it and I haven't yet. Okay, so we have the characters. We are filtering them with the comma. I'm actually gonna keep on collecting it like this because that's actually easier to read. And we are filtering things out. Let's collect it again into a string. Okay. Oh, this is bad. Okay, so it's actually better to debug the string as something else, unless you want to put debug breakpoints and stuff. So here we are collecting into a string. We have filtered out the comma. The next thing we want to do is have it to uppercase. So let's map it. And the map behaves almost like the JavaScript version. It takes a letter and we want to return the letter to uppercase. I think it's to uppercase or to ASCII uppercase. I think it's to ASCII uppercase. I'm just gonna put it that way and pray hard. Yay, I got lucky on that one. If you don't know, you can always go to the definition and the API of strs, which is gonna give you everything and anything that you can do with it. To ASCII uppercase returns a character, which is the uppercase equivalent of the letter that you have just passed in. Okay, so once we have this, the other thing we wanted to do is to actually map it into the value. So let's do that. Map, we have a letter, and now we want to get the Scrabble value. So let's map it to get Scrabble value of the letter. Is it gonna work? Oh, it's working, but it's complaining because it cannot collect it into a string anymore, which is correct. So what I'm gonna do here since I now have an array of integers, of U8, to be honest, I'm going to do it like that. Okay, so yeah, that's not what I want to do. That's a vec of U8. I'm going to do it another way. I'm going to iterate through the result for value in result, and I'm going to try to print it. I'm not really sure it's gonna look as good as it could, but let's try that. I'm gonna for a value and I'm gonna print it. Let's try to print it. Okay, that's better. So now I have a lot of nice little values. As you can, if you can remember that was what we had, almost what we had in JavaScript, and it just, since I've made a print line, it just has a carriage return before it logs it, but that's pretty good. Okay, now that I have the values, what I want to do is sum it. So I'm gonna just do it the same way I did in JavaScript. I first created a total, started with 0, and I'm gonna total plus equals value. So that would be the iterative version, I would say. So I'm gonna print the result. Let's say total is can I do that? Let's see how it goes. Total is 103. That's good. That's good, and it actually matches the JavaScript version, which is good. So the last thing I want to do is actually reduce it. Let's reduce it together. In order to reduce it, it's going to take a function. No, it's not going to take a function. This is the main caveat I always have between when I write JavaScript and when I write Rustlang. The Rustlang version actually takes the accumulator, the initial value first, and then the closure. And the closure would be something that takes an accumulator, something that takes a current value, and we are just going to return accumulator plus current value. All right, let's try to print that. It's complaining. Why is it complaining? There's no reduce for, oh, that's funny. There's no reduce for this. This here is supposed to be a U8. Oh, let's try to see what's going on. Cargo check. No reduce for, wow, that's a nice one. No reduce for this. And now that I have the Scrabble value, I'm supposed to have, oh, okay, I think I know what's going on. So the problem here, I believe, is that since it's a U8 and a U8 and a char have the same underlying values, it's kind of hard for it to understand what I want to do with it. And it's just telling me I don't really know what's going on because you are giving me characters and you are trying to reduce over it. Maybe I could actually, where is it? Filter, map, there's no reduce with that. That's pretty interesting. Okay, so we're going to do it another way. There's another way for me to do that is to actually not map, but instead I'm gonna ask for the value here. So what I'm gonna do here is I'm gonna start with 0, have an accumulator instead of the current value, which I haven't gotten yet. I'm gonna take a letter and I'm gonna ask for the Scrabble value of the letter right here. Okay. Let's see if I can do that. No, it seems I can't. What can I do? Cargo check won't pass. So it's telling me that it does not like me having a filter, map and filter. Let's try to do that another way, maybe. Oh, that's not a reduce, that's why. So you see, I have been careful enough to remember that the reduce function, which is actually default function. Now you have it. Default function takes the parameters in the other order, and I've been trying to actually call a JavaScript function in a Rustlang code, which is unfortunate, isn't it? I know it's complaining because I used current value. So that's a pretty silly mistake, which can actually be caught if you are a bit more conscious, I suppose, or a bit wiser. It's not too much of a big deal, as you can see. And the total is 103. So let's wrap it up. What have we learned today? We have learned for both in JavaScript and in Rustlang to split what is an array, how to get an array from a string, how to filter things out, how to map things out, and reduce or fold it, you name it, with respect to the language you're using. There are a couple of caveats. One I actually fell in, which is reduce is actually a fold in Rustlang, and both APIs, both array APIs, are very, let's say array, but it's actually iterator. Both APIs are very interesting, and you definitely want to have a look at them in JavaScript and in Rustlang. I'm going to put quite a lot of comments and things in the show notes. If you want to dive deeper and if you want to have a more thorough look at it, I'm probably going to create a repository with just both examples if you want to play a bit with it. And yeah, once again, if you have any questions, any comments, if you want me to talk about something else, just let me know. And yeah, I suppose that's it. That was Jeremy. Please let me know if you like the video or not, and I hope to see y'all soon. Bye.